Today we're going to be starting section 8.4, which is on multiplying and dividing rational expressions. And our goal in this section is to simply do that, to multiply and divide rational expressions. When we talk about a rational expression in simplified form, it's going to be when the rational expression has a numerator and a denominator that have no common factors other than plus or minus 1. Okay, so we have to simplify the numerator as far as we can with the denominator so that don't have any like terms. So when we look at simplifying rational expressions, we're going to let A, B, and C be expressions with B not equal to 0 and C not equal to 0. Then the following rule will apply. If we have A times C over B times C, these are being multiplied so we can cancel out the C's, and so we have A over B. And that's just like if we have 2 fourths, we can take a 2 out of both of them. We can split them up as a 1 times 2 and 2 times 2, and we can cancel out one of the 2's. So if we have a fraction like 30/70ths, we could rewrite that as 3 times 10 and 7 times 10. Well, we all know that those are going to reduce to 3/7. And so 3/7 would be our answer in that case. If we take it and look at it in regards to a polynomial that is factored, we're going to have 3 times, let's look at an example like this, 3 times x minus 5 times x plus 2 over x plus 2 times x minus 3 times x minus 5. Our goal is going to be to get these polynomials into factored form. Okay, we cannot cancel anything out until we get them into factored form. That way we'll be able to see what we can do with it. Now notice, in this case, I have an x minus 5 in the numerator and the denominator. Well, anytime you have something over itself, it's really 1. So x minus 5 divided by x minus 5 is 1. So those cancel out. I can also cancel out an x plus 2. And so if we do that, now this is going to be 3 over x minus 3. And that would be in reduced form. 3 does not have any common factors with x minus 3, so there's nothing we can do from there. So when we look at example 1, we have a polynomial in the numerator and a polynomial in the denominator. Okay, much of this section is going to be review on what do you remember about factoring. Okay, you have to be able to factor these polynomials. So we're going to take the numerator and we're going to factor this. So if we factor the numerator, let's do it down here. We're going to x and x. Factors are 16. So we're going to go 4 and 4ths, and they're both going to be negative. So that's how we would factor that one. The denominator is going to be x and x. 6 and 4, plus and minus. So we have those two factored. So now we have to look, do they have any factors that we can get rid of? Well, if we see here, they both have an x minus 4. Those will cancel out. And so our solution is going to be x minus 4 over x plus 6. And that is as far as you can go. You can't cancel anything else out in this problem because x minus 4 is one of our factors. X plus 6 is one of our factors. That's basically one number. So we got to make sure we do leave those in that form. All right, the next thing we're going to talk about is efficiency. Manufacturers often package their products in a way that uses the least amount of packaging material. One measure of efficiency of a package is the ratio of its surface area to its volume. Okay, the smaller the ratio, the more efficient the package. So the first thing we need to know is what is surface area. And it depends on what type of shapes that we're going to have. Well, in this example, example 2, we're going to be looking at a cylinder. So what we're going to do is look for the surface area of a cylinder is going to be 2 pi r squared plus 2 pi rh. Well, the reason this is because the base of the cylinder is a circle. And that we all know that the area of a circle is pi r squared. And then we have two bases, one on the top, one on the bottom. So there's our 2 pi r squared. If you unwrap the peel of a pecan or something like that, which is a cylinder, that shape is going to be a rectangle. Well, that rectangle will have a length of 2 pi r and a height of h. So that's going to be the surface area equation. And then the volume is going to be pi r squared h. So that's going to be the formulas, the 2 formulas that we look at with the cylinder. So it says the company makes kitchen canisters with the same base. Style 1 is cylinder's height is equal to its radius. So if we look at style 1, this is its radius r, then its height is also going to be r because they have the same. If we look at style 2, this is going to be a taller, skinny one because it says style 2 is a cylinder whose height is twice its radius. So this one's going to be 2r equals the height. So now we're going to set up which one is more efficient. So what we need to do is look at finding these surface area and volume of each canister. So the first thing we're going to do is look at style 1. Okay, so if we plug our numbers in for 2, here's our surface area is 2 pi r squared, and so this one is 1, and 2 pi r h. So we're going to have 2 pi r squared plus 2 pi, and now h is the same as r, so it's going to be r squared. So in this case, it's 4 pi r squared. That's the surface area. If we look at the volume, it's going to be pi r squared h, and so that is going to be pi r cubed. If we do style 2, we're going to do the same thing. Now, this time, we're going to plug in 2r instead of h. So it's going to be 2 pi r squared plus 4 pi r squared. And this is going to equal 6 pi r squared. And if we do the volume, again, we're going to put it into the volume formula. And instead of h, we're going to put 2r. So that's going to be, the volume is going to equal 2 pi r cubed. Okay, so we now have the surface area of each one and the volume of each one. So the ones in red are the surface area and the volume for cylinder 1, and the black underline is the surface area and the volume for cylinder 2. So now it says calculate the ratio of the surface area to the volume. So surface area to the volume of each canister. So style 1 is, we simply do that, 4 pi r squared over pi r cubed. And so we look at what can we cancel out. Well, obviously these pi's cancel out. We're going to get rid of the r squared, and that is going to leave us with just an r, so it's going to be 4 over r. Well, style 2, we're going to do the same thing. So it's going to be 6 pi r squared over 2 pi r cubed. And again, we cancel out the things we can. Pi's are gone, the r squared's gone, so I left with an r. And then this is going to be 3 over 1, so it's going to be 3 over r. So here are the 2 ratios. Then part C says, what do the ratios tell you about the efficiency of the 2 canisters? Well, if we look at this, we know that 4 over r is greater than 3 over r, so style 1 is less efficient. All right, so the next thing we're going to do is we're going to jump to a couple of guided practice questions. You can do a couple of these. I'll go ahead and do them all. Try a couple of them to see which ones you want. I would recommend at least doing 4, 5, and 6. Those are good ones to do. But go ahead and pause the video, and then you can hit play when you are ready to resume. And here are the answers in simplified form. Notice number 3 was already simplified. There's nothing we can do from that one. So the big thing in all these problems, you want to factor them and then take out the common factors that you can. All right, the next thing we're going to look at is multiplying rational expressions. Now the rule for multiplying rational expressions is the same as the rule for multiplying fractions. Multiply your numerators, multiply your denominators, and then simplify it. Okay, again, so here, if we look at this problem, A times C is AC, B times D is BD. So if we take a problem that looks like this, 5x squared over 2xy squared times 6xy cubed over 10y, we're simply going to multiply them straight across. So let's take the numerators. 5 times 6 is 30. I'm going to get x cubed, y cubed, over 2 times 10 is 20, x and y cubed. So now if we are looking at simplifying this, I can take a 10 out of both of these, so I have a 3 and a 2. The y cubes cancel out completely. They're the same. Now I have 3 x's and 1 x, so this is going to be x squared up here. And so really our answer is going to be 3x squared over 2. And so that's what we would get if we simplify this. All right, so jumping down to example 3. Again, and you can do this, you can simplify this in a number of ways. You can start canceling stuff out right away. So I could say, okay, I'm going to take this 5 out, I'm going to take this 15 out, and I'll have 1 up on the numerator and 5 down in the denominator. And I could take this 3 out of here and 3 out of here, and so I have 9 here. You know, you can do it that way as well. But the easiest way, so that you have everything in one spot, might be to multiply all those together. So if we take those, 5 times 27, we have 135. And I have an x squared and an x to the 5th, so that's x to the 7th. And I have a y cubed. So that's my numerator. Multiplied all my numerators. Then I'm going to multiply my denominators as well. 3 times 15 is 45. And I'm going to have x to the 5th. And now I'm going to have y to the 5th. So the nice thing about doing it this way is now we have everything in one fraction. So I can take a 15 out of these. And so if I take 15 out of here, I'll have 3 left. And I take 15 out of here, I'm going to have 9 left, which actually it looks like I could have taken a bigger number out. So now I notice they both have a 3. So I can take that out, and I'm going to have a 1. And this out, I'm going to have a 1. So we could have taken 45 out of all those. So we're going to have 3 over, and I have x to the 7th over x to the 5th. So those are going to cancel out, and I'm left with x squared. And then I have 3 in the top and 5 in the bottom. So I'm going to have 2 left in the bottom. So I'm going to have 3x squared over y squared, and that is C. Next, we're going to multiply rational expressions. And again, multiply the numerators, multiply the denominators. But the first thing you're always going to do in every single one of these problems is factor it completely. So we want to take out whatever we can do to factor this completely. So if we look at the first one, now notice the x squared term is last. Okay. I like to change it so that my x squared term is first, and I always want that to be positive. So what I'm going to do is I'm going to take out a -5, because I can do that out of both of those, and I'm going to get x squared, and if I take a -5, oh, actually I can take a -5x out. So if I take a -5, then that's going to be x minus 4. And I can take an x out of the bottom too, so I'm going to have x and x minus 1. So there's my first fraction simplified. Now I'm going to factor the second one. And the numerator, I'm going to have x and x, 4 and 1, plus 4 minus 1. And here I'm going to have x minus 4 and x plus 4. Okay. So now what we're going to do is we're going to look at, are there any that we can cancel out? And so I see an x minus 4 here and an x minus 4 here. Those are gone. I see an x plus 4 here and an x plus 4 here. Those cancel out. I see an x minus 1 and an x minus 1. And these x's are going to cancel out. And so actually the only thing we have left is -5. So this entire fraction is really -5 in simplified form. It equals -5. All right, example 5, we're going to do the same thing. Now, if you see a problem like this polynomial, you can always write it as over 1. That way you know that that's in the numerator, your 1's in the denominator. So once again, we have to simplify it first. So let's go x minus 4. Okay, so we're going to start by factoring it. Now, if you notice here, this is the sum of cubes. Okay, that's on your note card. Make sure you don't forget how to use some of these properties we've already talked about. So if we factor this, it's going to be x plus 2, and then x squared minus 2x plus 4, and then times x squared minus 2x plus 4 over 1. Well, if we look at this, we notice that this whole factor and this whole factor will end up canceling out. And so we're going to end up with the polynomial x minus 4 over x plus 2. And so there is our answer in simplified form. So we have 3 guided practice questions here. I want you to take a couple minutes, go ahead and do these 3 problems. Go ahead and pause the video, and when you are ready to resume, you can hit play. So if we look at the guided practice questions for 8, 9, and 10, notice once again, we factored all of these polynomials, then we went through and found what things can we cancel out, what common factors do we have, we simplified them, and so here are the answers. Now the last thing we're going to talk about today is dividing rational expressions. Well, dividing is the same as what we just did, with one exception. Okay? Dividing is the same as multiplying by the reciprocal. So if we look at the property here, AB divided by CD, we're just going to flip this upside down. All right, so we're going to take and multiply by the reciprocal. So if we cancel, then A times D over B times C, we're going to cancel out the like terms then, if there are any. So if we look at an example, let's say we have 7 over x plus 1 divided by x plus 2 over 2x minus 3. That would be the same thing as taking 7 over x plus 1 times 2x minus 3 over x plus 2. Because we're just going to flip this fraction upside down and make that a multiplication. So then our answer would be 7 times 2x minus 3 over x plus 1 times x plus 2. And then we'd see if there's anything we can simplify, and in this case, there is not. All right, so if we look at example 6, once again, the first thing we have to do is we have a division. I don't want that into a division. We want that changed into a multiplication. So realistically, it's going to be x squared minus 4x minus 21 over 5x plus 15 times, and we're just going to flip these two. X squared minus 100, x squared plus 3x minus 70. So now we're going to factor them. So we're going to take the first one, and we're going to do the factors of that. So that's going to be x minus 7 and x plus 3. And then take out a 5, we're going to get 5 times x plus 3. Next one, x minus 10, x plus 10, that's difference of squares. And then we factor this one, x and x, 70, so that's going to be 7 and 10, and a plus 10. So now we're going to look at what things can we cancel out. Well, we have an x plus 3 and an x plus 3, an x plus 10 and an x plus 10, an x minus 7 and an x minus 7. And so our answer is going to end up being x minus 10 over 5. And that would be our answer in simplified form. Example 7, now once again, is dividing by that. So it's going to be over 1. And so if we flip it, multiply, we're going to multiply by its reciprocal. Okay, so what I'm going to do is I'm going to factor these and flip them at the same time. So I'm going to start by my factors. It's going to be 3x and x. If we go 10, looks like it's going to be 5 and 2, with this being positive and negative, over 6x squared. And now it's going to be times, 1 is my numerator, and I have x times 3x minus 2. And again, we check to see what can we cancel out. And those are the only things in that case, so it's going to be x plus 5 over 6x cubed. So there will be the answer to that one. All right, so there's 2 guided practice questions here on the division. I want you to go ahead and try those. So go ahead and pause the video and hit play when you are ready to resume. And here are the answers to those 2 guided practice questions. So in summary, in this section, the biggest thing we want to remember to do is how to multiply and divide fractions. Remember, multiplying fractions, we're going to multiply straight across the numerators. Anytime we get a division, we're going to flip the second fraction and multiply by the reciprocal. So a lot of this section, what we need to do first is factor all of these polynomials completely, and then we'll be able to see which factors will cancel out in the numerator and the denominator so that we can simplify them. Right. So that is section 8.4.